create a tree, add a node, and test it somehow. That type of deal. Android Studio project. All right, we're gonna call this guy. Bitten Tree Simulator. That's probably down the path we're going or something like that. Have I just been putting these on my desktop or have I been putting them someplace? Oh, it probably doesn't matter since I'm throwing it in on GitHub anyways. So actually, this looks like it's going in downloads. That's fine. It's not going to hurt anything. All right. Oh, I didn't request new components, but cool. All right. All right. Oh, we want empty activity. Is this a new one? Bottom navigation activity? That wasn't there before, was it? So for extension to the boot camp, this is a iOS's equivalent of a tab bar view controller that I didn't show the other day, but hopefully you're starting to see this pattern. It's kind of the same crap on both sides. You just learn the little nuances of this is the Android way of doing it, this is the iOS way of doing it, but really it's what do they do? It's just like in the graphics card industry or anything like that. When one of them does something cool, the other one takes it. Then they do something cool, the other one takes it. And at the end of the day, you pretty much have the same kinds of widgets to build your apps, and life goes on. All right. Now everybody who's doing the hackathon has been in communication with their teams and they're brainstorming ideas. I strongly encourage you to get together with your team beforehand and make sure your laptops are all up to date and stuff like that. Meeting with one of my teams today. Is that your team? Is that your team's tomorrow? Tomorrow, yeah. I have two teams. Well, me and Mr. Gonzalez are splitting responsibilities. But yeah, one of my teams is today at 1, the other one's tomorrow at noon, the lunch thing. Okay. So bring your laptops so we can make sure everything's up to date and we'll decide what platform we're writing stuff for. All right, so let's go ahead. And I think last time we were talking about implementing a binary tree in terms of a tree of trees, correct? All right, so we're going to have this idea of a binary tree. So let's go ahead and we'll create a new Java class. We'll call this guy binary. Ooh, this keyboard. But, oh, speaking of which, hating this keyboard. I just downloaded this really, really cool VR RPG game down there. Nothing to do with the keyboard, but I wanted to talk about this. Oh my gosh, it's sick. I'm just totally enamored with the VR stuff now. Who in here has not had the HTC Vive on before? Everybody else in here has had it on? I waited a year. I just figured, oh, it's some stupid technology or something like that. I waited a year, didn't put it on. It's ridiculous. I'm like totally addicted to it now. So I was down there. I was like opening doors by throwing a skull at it this morning. It was so cool. So this game, I mean, it cost money. It was like a $40 game or something. So I bought it. But it's like an RPG where you're doing like a dungeon crawler, running down hallways and stuff like that, and dealing with magic. And I was stacking apples on top of each other. I wasn't supposed to do that, but I got kind of sidetracked. But I'm just amazed by this thing. I could just live in there. In fact, I did. I was in VR for 3 hours this morning. I'm still kind of coming out. You come out, your eyes are all bugged out, and it felt like 20 minutes. And Curcio's like, you got class in 5 minutes. He had to take one of my earphones out because I was totally immersed. We had to remap the room because they kept stepping on the printers. The 3D printers, the expensive ones. It was like really expensive printers. All right.
Any like long-term brain kind of?
I don't know. I'm a lost cause at this point. So I've forgotten so much more than like most people ever learn. So it's just like an empty tank at this point. It's just gone. But yeah, we'll find out. Check with me in a year. Okay. But I'm basically eating through a straw or something. Then we'll know we need to go back and revisit this VR for health thing. So for a binary tree, we're going to have a payload. And I think we decided for this guy, we'd have what? We're going to hold integers. Okay, so we're going to have an int payload. So we'll have a private int payload, call it whatever you want, but kind of data structure jargon, they're usually called payloads. And historically, we've created node objects that had payloads in them, right? All right, so, and then we have a private binary tree. We just call it left. All right, we call it left tree. Let's call it left tree. And then a private binary tree, right tree. Okay. So last time I mentioned this phrase to you, and this is more of a Lippmann phrase, this pseudo recursion, or is that what I called it? Pseudo recursion? I make it up each time, I think. But, in this case, we're implementing a binary tree in terms of itself, right? But these are different instances of itself, so that's not true recursion, but it kind of looks like recursion. And even in many ways acts like recursion from a problem-solving perspective, but doesn't necessarily, actually I was going to say it doesn't necessarily act like recursion from a memory perspective, but it really does, because if you're making a call to another method, whether it's your own method, a method that looks the same that's owned by a different object, it's still another method that needs to be thrown onto the stack and stored. So it's going to have that same level of memory inefficiencies. But maybe for us, that kind of puts it into some perspective for us, is that it's not that recursion is the only guy that's memory inefficient, right? Whenever we make multiple function calls, we're taking up some more memory because things need to be stored. So with that in mind, don't necessarily view recursion as being horrible. Because we're kind of doing the same stuff that recursion is doing anyways every time we call a function. Where recursion gets dangerous is when you're, unnecessarily having to go down a whole bunch of levels to do something relatively simple, where you could have maintained that in a significantly smaller memory footprint without drastically changing the difficulty of the solution to the problem or something like that. Okay, but don't be afraid of recursion because of its negative ramifications related to memory, but do keep it in mind. Okay, so we have a payload, we have a left tree and a right tree. So when we create a binary tree, so we'll have the constructor for this guy. Oh my gosh. I need to do all my programming in VR, so I just have this giant keyboard I can slap with my hand for the...
Build for real life in VR.
I'm going to. I'm just going to have one. I'm going to get like a telepresence robot. I'm just going to be sitting in the room completely in VR, and the robot's going to go do all my stuff. Like bring me food, feed it to me. Now we're back to the straw thing. I'm just sitting there in this chair. It just comes back and refills my container. And I just keep slurping. It sounds funny, but this is probably true where we're going with society one of these days. All right, so when we build a binary tree, we're probably going to go ahead. I think I mentioned this last time. We might have two different constructors. We might have a constructor for like an empty generic binary tree that we then add a value to. Then we might have another constructor that allows us to build the binary tree with a payload. Okay, so we'll go ahead and build both of these. So what I'm going to do to make that work, and if you didn't write yours this way, that's okay. It's not going to be the end of the world. I'm actually going to create a private Boolean called isSet here. And for the empty binary tree, the generic one that doesn't actually have a payload set, because with an integer, we can give it a default value, but how do we know that that's not the real value we're trying to store? So I'm going to have a little Boolean that lets me know whether the payload for this tree has actually been set. So here, for a generic binary tree, I'll say this dot isSet is equal to false. I haven't set a value for this guy yet. All right, and then I'll say this dot left tree is equal to null. This dot right tree is equal to null. All right, I'm not going to touch payload here because I don't have a payload. Now I'm going to have a second constructor, binary tree, and this guy is going to take in an int. Yay. init payload, and I'll say this dot payload is equal to payload, and I'll say this dot is set is equal to true. This dot left tree is equal to null. This dot right tree is equal to null. I'm going to actually, just to show something here, wouldn't you say, well, this is kind of a loose example, that these two lines, we're duplicating them from right here, right? So we're going to say maybe that's not the greatest. Why duplicate something if we already have something that lets us do it? It's only 2 lines of code, so maybe it's a toss-up type thing. But just to show a technique that I don't think I've shown you before, we already have a dude who knows how to do that. So what I'm going to do right off the bat here is I'm actually just going to call upon the other constructor. Actually, it's not. Ooh. Can I do that in Java? I may not be actually. Can I do that? This will be very interesting, actually. I don't know if I've ever tried to do this way. Usually you would do this in the inheritance model to have your parent set up, call his constructor. So I'm thinking this is going to work. I'm just replacing what I know about the super keyword with this keyword. So what I'm going to do here is when we call this version of the binary tree constructor, the very first thing I want to do is I want to go ahead and I want to call my other constructor. That is the default constructor that takes no parameters. And we'll see if this works. And this guy, and then after that comes back. When this guy goes, he's going to is set to false, and he'll set both my left and right tree to null. Then I'm going to go ahead and say, okay, well, I'm going to go ahead and give the payload a value, and then I'm going to flip is set to true, even though it got set to false initially. All right. Just to test this real quick, I'm going to make this guy public, if that's okay. So I want to see if this works before I go too far down the rabbit hole. Okay, so when I create a binary tree and I pass it a payload like a 5, what I really want to happen first is I want this guy to call the more generic constructor, have him go ahead and initialize my left and right tree to null, and even though I don't really want this, he'll go ahead and set is set to false. Then I'll do the specialized stuff that this constructor is supposed to do, namely setting the payload, and then actually after I set the payload, marking the payload as being set. That makes sense? So that's what I want to accomplish here. I want to see if this line actually does what I expect it to do. Historically, in the inheritance model, I would have said super, open close parentheses here. My belief is this should act the same as that guy, so let's find out. Do you happen to know if it works this way?
Well, I feel like it does, but
It looks like it should. It's not complaining about it. But to be honest, I'm not sure if I've ever actually tried this before like this. So that kind of goes to, and I've said I've been writing Java since it came out. So, this just goes to show that you run into new things all the time that you haven't actually tried before. So this is really an experiment. If it works, I knew exactly what I was doing. Okay, if it doesn't work, I did this on purpose just to show you that sometimes things don't make sense or should make sense. Whatever. So in here on onCreate, I'm just going to go ahead and I'm going to create an instance of my binary tree BT, and this is going to be a new binary tree, and I'll use the payload one, so I'll pass this guy a 5. And then I'm going to go ahead and I'm going to do a system.out.println. I'm going to give myself a whole bunch of asterisks here so I can actually see it, so I don't have to hook it up to a label just while I'm doing this. And then I'm going to throw out bt.isSet. And if it's true, we know it did what we expected it to do, right? If it's actually, is that a true statement? Yeah, I think so. So if this is true, it did what we expected it to do. If it's I'm actually going to test it a little bit differently. I'm going to start it off as being true, and I'm not going to change it here. So if it gets flipped to false, this definitely does what I expected it to do. That means it did call this guy. and flipped is set to false. And then I'm not going to do anything with it here. That'll just prove to me that this line right here is in fact calling this constructor. All right, so that's what I'm just testing here real quick. All right, create my tree using that second form of the constructor, which should call the first form of the constructor, which should flip is set from true to false. So I should see a false here when I run this. Let's see what happens. All right, and then let's look at, where's my line for it? It's not terminal, is it? No, it's not terminal. This dude? And then it's logcat, right? Oh, here it is right here. False. So it's, yep, so that means it got called. Start off as true, got flipped to false. All right, so I knew it was going to work all along, obviously. Okay. But, really, this is actually a pretty good example of when you learn some fundamental truths in programming, you can then apply that as, let's call it an educated guess towards something else. All right. Now, with this in mind, I'll go ahead and I'm going to flip that guy back to true. Well, I just won't initialize it up here. It wouldn't have made a difference. All right. So now it should go back to the way I want it to be. Let's just run it one more time and make sure it undoes the setting it to false, right? So it starts off as nothing, probably some default value. I'm guessing maybe false is a default value. When I call the other constructor, it'll flip it to false, and then I'll flip it back to true. So it should be true when I run it this time after it's flipped it back, proving that the control did come back here. It should. Significantly more confident on this one. Yeah, there's my true. All right, so we're good there. But anyways, what I was saying is when you start learning different patterns in computer programming, you can then make a pretty, I mentioned this in earlier classes about how important it is to be able to read documentation, right? Because you're not going to memorize an entire language. You're not going to use every single object that comes with every single language. I've kind of made some statement before that I've been writing Java since it came out. My guess is I've used less than 15 or 20% of the language, and it's probably way less than that would be my guess when you do the all classes and you see just the wall of objects. So it's, but by learning how to do those fundamental moves, you then can apply that knowledge to other stuff. And that was kind of what we were trying to do at the boot camp the other night, right? We looked at, here are some fundamental things you can do in iOS, and we've done it here with the Android stuff. Now apply that to a new thing that you haven't necessarily worked with before, but we can all throw a brand new widget on the screen in an iOS, on an Android app for us in here, and then create a variable for it, right? Whether you know how to all the things that guy might be able to do is a different story, but you can do that part based on knowledge from something else. All right, so when we build our binary tree, we'll go ahead and have this guy do the initial setup of really flipping both those guys to null. In this case, it's really a coin flip. But this let's say that there was 300 lines of setup code in here. Don't copy 300 lines of setup code into here and duplicate it. Instead, go ahead and leverage those 300 lines of setup code through this guy, and then do your specialized setup for this constructor. If you're not comfortable with this, you could then also create a function or a method in Java that does those 300 lines of setup code and have both constructors call that method. It's all the same thing. The punchline here is try not to duplicate code too much. If we're talking 1 or 2 lines, that's just duplicate it. It's not the end of the world. But if you have like a major logic block, don't duplicate that. Why do you think that is? Why should you not duplicate code into as today's programmer. I want to see if you stumble into the wrong answer. Let's say you have 5,000 lines of code. I'm trying to trick you, by the way. You have 5,000 lines of code, and I'm telling you, don't duplicate those 5,000 lines of code. Use the code you already wrote. What's the advantage of, why wouldn't we want to duplicate it? Go ahead.
You have to change something, it's only one place you have to change it. If there's a bug, there's only one place.
Yeah, see, she didn't follow my trap. She got the right answer. Okay. Okay. I mean, a logical answer, and something that would have been a right answer historically would have been 5,000 lines of code is a lot of code, right? That's space. That's the amount. That's the file size. That kind of stuff. We don't care about that now, right? You got terabytes and terabytes of stuff. Who cares about another 5,000 lines of text? Okay? It's meaningless. Okay. So that's not of concern to us today, but that's a big deal. That's the reason why we use constants. That's the reason why we have functions that we can reuse, because if you introduce a bug, okay, so let's say in those 5,000 lines of code, you introduce a bug. And instead of having that 5,000 lines of code in a function that you call multiple times, you duplicated it here and duplicated it here and duplicated it here, and you forgot you duplicated it over here. Now you fix the bug here and here. The bug still lives here. And that can happen because you're 6 months later after you've written the code the first time, you've forgotten that you even wrote that. But if you write your code in a modular way where we're saying, oh, here's 5,000 lines of logic, all three of these guys need it, I'll put it in this function right here. Oh, I've noticed that there's a bug with these 5,000 lines of code. You go and fix it, and now it's fixed across the board for those three places that are using it. That make sense? All right, so that's the real reason not to duplicate code. Reduces the number of bugs in your program or something like that, or at least reduces the number of places you have to change stuff. And I think we even saw an example of that last class, right? Where we weren't sure exactly how we wanted the labels to show up. So I think I put the little vertical line, like a space, vertical line, space, or something like that to separate our values in our stacks. So I didn't actually make it as a constant. It's created as a variable. In Java, if you want to make something a constant, you put final in front of it, and that makes it a constant. Means that the value can't change. Okay. So I didn't do that. So you could have changed the value if you wanted to later on. But the point is that then I could use that in 10 different places, and if I decided I didn't like the way it looked, I only had to change in that one spot, and I could then test the program again real quick, and all 10 of those places are using that one variable to put the separator in there rather than me having to go change the string in 10 different spots. Make sense? All right, so creating our binary tree, we'll go ahead and let this guy do the basic initialization. Then I'll do the extra initialization of saying, oh, he wants to set the payload, and I'll go ahead and mark that payload as being set. All right. Now, we're supposed to have a add a value. So we're adding a payload. All right, so we'll say maybe have this guy return maybe initially return a Boolean. I didn't have you do lexical address, right? We talked about it, but we didn't actually do it. Okay, so we'll say public Boolean. I don't know. What do you want to call it? Just add. Let's just call it add. Int payload. All right, and we're going to try to add the payload to this guy. Now, if my payload is currently not set, I can just add it right here, right? I don't need to ask any questions. So if this dot is set, if not is set, that is, if this dot is set is equal to false, then what are we going to do? We're going to say this dot payload is equal to payload, and we'll say this dot is set is equal to true. Make sure we flip the switch, marking this guy as having a payload that is now set. And then we'll go ahead and return true. Job's done. Make sense? Otherwise, and we could put this in an else if we'd like, you know, if you're more comfortable with doing the else's, and maybe even structurally, this makes more sense. You know, you kind of have two approaches, and I've called this approach here, let me take the else out for a second, where, you know, we do other things here. I kind of called this the minefield approach. If we're still kicking after we hit this, then we'll just keep doing things right down here, because this return statement makes this function immediately end. Make sense? But if you're more comfortable throwing an else in there and you just like that that division, it's not going to hurt anything. All right. So if it's set, set it. Otherwise, let's find out which of our trees it should get set for. All right. Now, the first thing we need to add, well, let's find out which side it should get set for first. So we're going to say if the payload we're trying to add is, what did we say last time, less than or equal to? If it's less than or equal to the payload we already have, and we know that guy will have a value in it because we wouldn't be in this else if it wasn't already set. All right. So if this guy should go to the left, then we're going to try to add it to the left. Now, if I don't currently have a left tree, I don't want to talk to that guy about adding a payload to him, right? Instead, I want to go ahead and create a left tree with that payload. So I'll say if, and you could have done these with some ands and stuff like that, but I'm kind of walking through this. So I'll say if this dot left tree is equal to null. If I know this guy needs to go to the left, and I don't currently have a left tree, let's go ahead and create a left tree. This dot left tree is equal to a new binary tree, and we'll pass it the payload we're trying to create. And then we'll return true. I've added him. I know that's where he landed. Okay? Fresh tree. He'll fit. Okay? But if I'm in this else, if I'm in the else here, this means, well, here, I'll just say, this means I have a left tree, and I'm going to ask him to add this payload, or add the payload to himself. That makes sense? I'm passing the buck. Okay? But I'm also going to be reliant on him telling me the final answer, and this is what you were dealing with before. So I want to return the answer given to me when I've asked my left tree to go ahead and add a value, the payload that I was trying to add here. I couldn't do it myself directly. I couldn't set my payload to it, and I couldn't just create a left tree because I didn't previously have one and just say his payload is this new guy. It was out of my control. So instead, I'm going to yell down to my left tree and say, hey, I have a payload I need to add. I can't do it myself. Take care of it. I'm delegating this responsibility. All right. Tell me when you're done, and I'll go ahead and return that answer. Make sense? All right. So that's all the stuff we do if the payload should go to the left. If the payload should go to the right, so we'll just say add this payload to the left up here as a comment. This guy is going to be add this payload to the right. So that means it's greater than this dot payload. I'll ask if this dot right tree is equal to null. If I don't currently have a right tree, then I'll say this dot right tree is equal to a new binary tree, passing it the payload, and then I'll say return true. I'll create my right tree, I'll create them in terms of the payload I want to add, and I'll go ahead and say done. I didn't have a right tree before, I created one. With that payload, the guy's been added. I'm done. Else, I need to go ahead, so we'll steal that comment there. I have a right tree, and I'm going to ask him to add the payload to himself. So I'll go ahead and return this dot right tree dot add payload. let him do the work. That makes sense? So as we go through here, if I didn't have a payload set myself, if I didn't have a value, which would really only happen under a very specific circumstance. This is kind of like equivalent to our linked lists when head is equal to null. It's kind of that guy. All right, so understand that this little extra logic that we have here, as well as having the two different constructors here, is kind of exists to support this concept of having a binary tree, which is a collection of binary trees, instead of having, I guess, a binary tree container that holds binary tree subtrees or something like that. Getting away from the linked list and node model, having two different types of objects. So we did need to augment our object here a little bit to kind of support that feature. That makes sense? Now understand that it's not wrong. If you wanted to write your binary tree in such a way that it held a bunch of nodes, that's okay. Life goes on. It's the same structure, you're not able to think about it in terms of it being a collection of trees. And I think there's benefit right now dealing with trees to think about it like a tree. That the left guy is just like me, except he's, really it's just a pyramid scheme of one of those get rich quick things, right? It's like, well, I'm not going to do the work. I'll pass the buck to this guy. I'll make my residual 10% off of it. All right. What was I doing? Okay. So if I don't have a payload set myself, just set it. I'm done. This is just going to be for that very starting point where I had an empty binary tree I added a value to. Otherwise, if the guy should go to the left and I don't already have a left tree, create a left tree with that guy in it and return true. Otherwise, if I do have a left tree, ask my left tree to add the payload. Else, he should go to the right. If I don't have a right tree, create one with that payload in it, return true, job's done. Else, ask my right tree to add the payload. This is that pseudo recursive call that we talked about last time. That make sense? Okay, so that should be our binary tree, something along the lines that you guys did for your homework. Now we need to kind of figure out a way, how do you test it? Make sure your stuff got added. Okay, let's see. I mean, really kind of the easiest way to test it is with well, I don't know about easiest, but it's with a lexical address type thing. But one thing we can do is let's teach a tree how to display itself. Okay. Right here. So we'll say public void. We'll just do it as text right now. Public void display. So to display itself, he's going to ask the question, do I have a payload? If I don't, say empty or something like that. So if this dot is set, if not, this dot is set, go ahead and do a system dot out dot. Let me think about this. I'm going to do prints in here. I think I'm going to do prints in here. Yeah, it's going to start looking funky anyways. So I want to have it kind of go down. We could do it with slashes, I think. It'll look funky, but I think we'll be able to follow it. All right, so I'll go ahead and do a print of my payload. So if I do have a payload set, I'll go ahead and print my payload. Let's just do println and move on with life. All right, we'll println my payload. And then if this dot left tree not equal to null, I'll say this dot left tree dot display. Tell him to display himself. If this dot right tree not equal to null, I'll say this dot right tree dot display yourself. If I don't have a payload, I'll do a system dot out dot println empty or something like that. It's an empty tree, which would only be our top level, right? Otherwise there cannot be a tree that exists without a payload. The only way for a tree to be in existence that doesn't have a payload would be for us to use that original constructor for the empty tree. So here we'll say empty tree. Okay, otherwise we will print the payload, kick it down a line, and then ask its left tree and its right tree to print the payload. So we're always going to go down the left side first, and we'll then go down the right side finally afterwards. So they'll be in a weird order because of the way we're visiting them in the order of the pseudo recursion. But it should let us see the values, right? Okay, so that's our display. Now let's give ourselves, let me open up. Display is not going to work.
Well, it's not gonna give you what you want.
Oh, let's see.
The initial
If it's not set, oh, it is set. Thank you. If it is set, then show it, do the left and right display if they're available. Otherwise, if it's not set, it's an empty tree. Good. See, I was testing her, she passed. The rest of you just idiots. That was such an obvious mistake, right? Just sticking out like a sore thumb. In fact, I believe I even went back and I added that exclamation point after I finished writing the word. What's up with that, Van? Didn't catch that? Sleeping on the job back there? See, Gabe sleeping on the job. I've seen Gabe doing some head bobs back there. Long night? I like Gabe. He's good people. And he's got some height to him, really. Actually, I don't even know. Are you taller than him? How tall are you? 5'11"? How tall are you?
5'6", maybe.
5'6", but you're barely taller than my wife. Seriously.
I mean, I ended up at the height in between my parents. So.
Yeah, it's true. Your dad's not a real tall guy.
Yeah.
Is your mom taller than your dad?
No, she's like 5'4".
Okay.
So yeah, I ended up in between.
Yeah, I don't know if we had the discussion in here or was in a different class, but I have this perception that everybody's at least 6 feet tall. That's not true. It's like weird.
That's mine too.
Yeah.
I don't think it's because
I never knew life. I don't remember life south of 6 feet.
I do.
Yes, I was almost your height in third grade.
Must be nice.
I don't know. I don't know if there's, because I think the advantages are also the disadvantages.
That's fair.
So I can get to the high places really easily, but I don't like going to the low places.
I actually got over being short a pretty long time.
Oh, I would expect so, because I mean you're stuck with it now. Yeah, I'm guessing you hit your growth spurt. So yeah, I told you my doctor said I'm too short for my weight. So yeah, if I was like 14, 15 feet tall, I'd be average weight. So I'm waiting for that. I don't know, was there a second or third growth spurt? Was it third growth spurt? I think you hit 2, don't you? You're going to find out. You have a 2-year-old, right? 10-month-old. Oh, yeah. You're going to hit 1 and then.
she's already half the height of my wife already. I tell her that all the time.
So she got your height.
It looks like
It looks like it. I gotcha. Okay, so let's go test this guy. Let's open up our keynote, though. That way we kind of know what to expect, and we'll add things in a certain order. I think we did this last time, right? So we should have a test case. Okay, do we remember which order we added these dudes? Let's just, here, let's We'll move them over here. All right, let's give ourselves a running list of. All right, so we added the 6, right? And then let's add the 5. Okay, so 5 is gonna drop in here. This guy's already taken. Should it go to the left or the right? Should go to the left. So we're gonna have that guy. All right, then let's add the 7. It should go to the right. So we're gonna have that guy. Then let's add, this 5. So this should go to the left, and then this should go to the left. That guy. Let's add the 4. So it should go to the left. This should go to the right. Then we'll add the 3. This should go to the left. This should go to the right. This should go to the left. Then we'll add the 7. This should go to the right, and then it should go to the... Nailed it. And he should go to the left. All right, so that's our 7 here. And then we'll add our 5. So it should go to the left, then it should go to the left, then it should go to the left. All right, so that's what our tree should look like. So when we see this actually print out, because the way we're printing it out, what do we expect to see it print? We expect it to see a print out of 5 if we're doing a print len. I'm sorry, a 6. Then we kick it down a line. Now it's going to print out the payload for that next line, which is a 5. Then it's going to print out, go to his left tree, tell his left tree to print himself, which is a 5. Tell his left tree to print himself, which is a 5. Tell his right tree to print himself, which is a 3. Then the other guy is going to tell his right tree to print himself, which is a 4. Then we're going to have the top guy tell his right tree to print himself, which is a 7, which is going to tell his left tree to print himself, which is a 7. I believe that should be the order of our display. Is everybody? Do we agree? You don't agree?
Well, your tree got put in wrong.
A tree got put.
The 4 should not be to the right of the 5.
Oh, yeah. What did I add that for? Add that for. Would that have impacted stuff? It would have impacted stuff. Yeah. That's a bad tree. Get it back. You should have stopped me back then.
Somebody else did it.
All right, so I got the. All right, I'll just. Doesn't take that long. This would have been accurate for this tree. It just wasn't an accurate tree. All right, so we'll do 5 first. Then we'll do 4, so that's left. Then we'll do 7, that goes to the right. Then we'll do 5, so that's left, right, correct? All right. Then we'll do 3, so that's left. Then we'll do 7, so that's going to be right, then left. No, yeah, less than or equal to. And then we'll do 5, which will be left, then right, then left. All right, so then our order is going to be a 6, then we'll do the left tree, which is a 5, then we'll do the left tree, which is a 4, and then we'll do the left tree, which is a 3. Then we'll do the left tree, which is nothing, then we'll do the right tree, which is a 5. 4, 3, 5. Why? I'm hitting enter. I promise. Got that 5. Then we'll do the right tree of the 4, which is another 5. Then we'll do the right tree of the 5. No, that's not the right tree of the 5. Then we'll do the right tree of the 6, which is a 7. Then we'll do the left tree of that 7, which is a 7, and then we're done. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Okay, look good? Okay. So 6, 5, 4, 3, 5, 5, 7, 7. That's what we should see printed out here. All right, so let's go in here and we'll tell our tree bt.display to go ahead and display itself. We'll go ahead and run this. to our monitor. Printed out the. What did I just get the 5? Oh, I gotta add the rest of my stuff. Testing you. All right, 654. I probably should copy this. All right, there's our 6. Then we'll see bt.add 5. Four, 7, 5, 3, 7, 5. 4, 7, 5, 3, 7, 5, 3, 7, 5. That look right? Okay, and just for the sake of testing, I'm going to go ahead and steal that text. All right, so that's what it should ultimately display. Now let's run it. 654, 355, 77. All right, looks good. All right, so that's the homework assignment. So let's go ahead and check this into, that's all you're supposed to do for the homework?
Well, you were supposed to get your value from the screen.
Oh, that's right.
what you need to do.
Yeah, let's go ahead and write that real quick so we have it because we're going to be creating an interface. Okay. Well, I'm going to probably need that. So let's get rid of that. Nailed it. All right, so we'll give ourselves a linear layout. Didn't we see these were backwards last time? That should be a vertical one. No, it's right. I thought it was backwards last time. Get rid of that label. Have this guy. All right, so now he's taking up the whole screen. We'll go ahead and give ourselves a edit text up there. Is that edit text? Just let me do edit text. Doesn't seem like a very, oh, there we go.
Why did it give you a constraint layout?
A who?
Constraint layout.
Where?
In the component tree. Why did it give you that? You just did normal empty activity.
Oh, yeah. Is that a new guy?
Well, I've seen it before. I don't actually know what it is.
That's, I don't know either, but that sounds like on the iPhone side of things, Apple has something called auto layout, which creates constraints of things relative to each other. So this was maybe the upgraded naming convention for a relative layout. So maybe eventually I'll start using just that, but I don't know. I like making my Android interfaces the stacks of stuff. For simple interfaces, that seems to work well. I suppose the second you want to make a more, gorgeous looking layout or something like that, you hire somebody who knows how to make things look good. I usually have either Caesar or Lupe do all my interface design, which would be problematic, as you might expect. Okay, so we need an edit text. Where are my edit texts? So they're not containers. You think they're under text? Aren't these labels?
No.
Where's the label? Where's the text views?
It's under widgets.
Oh, those are under widgets. Okay, so text views are under widgets. Edit texts are under text. Okay, fair enough.
Doesn't make much sense.
All right, fair enough. All right, I'm reading in a number. All right, nailed it. And then we're going to put a hint in there. Enter number. And the number thing, all that does is it gives you the correct kind of keyboard, what should automatically pop up. So if you didn't use that, life will go on. We'll center that guy. Okay, then we're going to give ourselves a button. That's under widgets. Nailed it. Say add to tree. Okay. And then we'll actually have our tree below that. Let's just do it as a stack right now. So what I'll do is I'm going to go ahead and add a new, it's horizontal or vertical? I'll add a new vertical linear layout here, which will be my actual tree. And maybe for right now, we'll just put text views in there to give us our stacks, and then we can figure out how to maybe make that a little, I don't know, nicer or something. But I think I mentioned last time, if you try to make a tree look pretty, it's not going to look so pretty, or it'll be difficult to make it look pretty. We maybe could actually pull it off on here without too terribly much trouble using a vertical linear layout of horizontal linear layouts, and then put empty edit texts in there as almost like tiles, to kind of space it out the right way. I'm not sure we need to go to that extent, but we could if we really wanted to go down that path, we could. So let's give this guy, we'll call him the tree. So the tree is going to be that view group, right? So I'll make sure I use a view group first this time, so because Emma usually has to fix that. I usually get it wrong, and I don't understand why it doesn't add. And then she says it should be a view group. Actually, she's usually nice about it. She goes, "Oh, maybe that needs to be a view group." She knows it has to be a view group. So
You want to use the right syntax on your button press method, though.
Not me. What, did I use the wrong syntax before? Or the on-click thing?
The
drop down?
The bracket at the top of your method, I mean. So that it'll pick up your button. And the drop down, you don't know what I'm talking about. The right squiggly bracket. Are you going to have it on your...
Am I going to use Emma style or correct style? Is that what you're saying?
Yeah. What do you
I don't know. We'll have to see. Because I don't know the next thing I'm going to do in 5 seconds right now. I don't. All right, so we want to have, we need to definitely get access to this button here, right? So let's call this guy our input ET. All right, so that'll be that dude. And then this button, we don't need to have access to the button itself, but we're going to have a on click for that dude. All right, so let's go into our main activity here, and let's give ourselves... Here, as an act of solidarity, we will leave that in Emma format. It's going to bother me, but I'm going to force the issue because she got the answer right earlier, and yeah, so we'll just do that. What's this guy screaming about? Do you want to terminate the running process? Sure. Okay. What was I doing? Oh, yeah, we're going to have our... edit texts, and this guy's going to be our input ET, and then we're going to have our private view group, right? And this guy is going to be our, we'll call this guy the tree, and that's it. Those are only widgets we have right now, correct? Okay. So then what we're going to go ahead and do is we're going to hook those guys up. So we'll say this dot input ET is equal to the edit text version of this dot find view by ID r dot ID dot input ET. Okay, so for those of you who did the boot camp the other day, that's the click and drag from an iPhone over to the variable in your code. So Apple does it that way. It takes more time than it just took us to do here, but maybe makes more sense the first time you learn it. Then we'll say this dot the tree is equal to the view group version of this dot find view by ID r dot ID dot the tree. Okay, so now we have access to that guy. Then we're going to go ahead and let's make our binary tree up here. So we'll say private binary tree. We'll call this guy BT. And we're actually going to use our blank binary tree for him. All right. So when we first launch the app, we'll have a blank binary tree with nothing in it. Now we want to have a method for adding stuff to our binary tree. Correct? So we'll have public void add button pressed, something like that. View V. All right, I did it. I did Emma syntax. Man, yeah, I assume you get used to it. That's what you're saying. I didn't like the way that looks. It's like one of those foods that just doesn't look good but might taste all right. Can't come up with one of those right now, but they exist. Oh, I know, like fried butter. Ever had fried butter? You gotta go to State Fair at some point. Take a stick of butter and they batter dip it and then fry it. And it's kind of like oozing and stuff like that. And then you know it's fried butter. Look at it, it's like, how good? It's so good.
I skip the deep fried Oreos.
Didn't they have those in the calf not that long ago?
Really?
I'm pretty sure. I think the calf had deep fried Oreos like last week sometime.
Probably the one day.
Yeah. I didn't have them, so I don't know if they were legit or not, but they did have them. Okay, so add button press. What is this guy going to do? He's going to go ahead and grab the number from our input ET and add it to our binary tree. So we'll say this dot bt dot add. We're going to add an int, so we're going to add integer dot parse int. What int? This dot input ET dot what is it? Is it just text or get text? Get text, which is an edible dot toString. Like that. Okay. So that will start adding stuff to that. Now what we want to do is we're going to augment our binary tree a little bit. So this is kind of Terminator style, right? So now we're going to pass into our binary tree the stack that is the tree, the tree. Okay, the view group that holds the visual representation of our tree. So every single time we add something, we'll go ahead and in that label, we'll create a label and drop it into that tree. Okay, so let's go into our binary tree and we'll create a private. I'm actually the order doesn't matter, but I'm gonna put it underneath payload. That way this is like the stuff that belongs to this particular tree. Oh, you know what? You could actually make this work okay for displaying a tree. If you passed in the original tree here for our, we're given the original view group, but every single time you build another tree, you create a view group that you pass to it, and then you add that view group into a horizontal linear layout. So this view group is a tree. This view group is a tree. We'll add a tree, then another tree. And they actually should lay themselves out all right. We won't do it right now, but there's potential for that, which actually leads itself into that whole idea of a tree of trees. How do you make a tree show itself? A tree is a view group. Okay, so whether I'm dealing with the top level tree or one of the sub trees, they're a view group. This is a tree that looks like a tree, and then we can then move the trees around. Oh, it's legit. All right, so we're going to go ahead and we're going to give this guy a private view group. We'll call it the tree stack thingy. Let's call it the tree view. The tree view. All right, so there's our view group for that guy. Now, down here in our binary tree, we're going to have this guy take in a view group, the tree view, and we'll also have this guy take in a tree for view group. We'll go ahead and pass the tree view to our constructor here. And we'll say this dot, the tree view is equal to the tree view. So notice that now my constructors, I have one that takes 2 parameters, an int and a view group, and the other one that just takes a view group. So now I had to change the way I called that other constructor by passing it the tree view. Okay? So now all my binary trees will know about that vertical linear layout. All right, they all have that guy now. So down here in add, whenever I set a payload, I want to go ahead and add this guy to the view group as an edit text. Okay, so what I'm going to do is we're going to say we'll make this private. Private add text view to tree. And this guy is going to take in an int payload that we're adding. And then we're going to go ahead and create a text view. And I think, do we need the context as well? All right, so we're going to have to take in our context. So it's a context. So we'll say private context. Let's call that guy context. So we'll have this guy take in a tree view as well as a context. We'll have this guy take in a tree view as well as a context. Then we'll pass the context up there. So an activity will send in the context with it. All right, so add text to, this guy's going to be a void. So the text view, we have to build in terms of this dot context. We'll say this dot, actually it's not this dot TV, it's just TV dot set text, the empty string concatenated with payload. And then we'll say this dot the tree view dot add view. Does it always add it to the end or is it added to the top? The end? Okay. So we'll just do the normal add view and we're going to add TV to that guy. All right. So here's an example of writing code once and then calling it multiple times because we might change the way we want this to add later on. So whenever I want to add a new label to our vertical linear layout, I'll go ahead and call add text view to tree. Okay, so we'll come down here. Well, we'll get to that here in a second. Let's fix it back here in main activity first. We create our binary tree. We need to pass it the tree. And we need to pass it this for the context. That's how we originally build that guy, so he has access to those widgets. Here in binary tree, when we create a new binary tree, we also need to pass along the tree view and the context. Right? Isn't that what binary tree takes? Yeah, payload, tree view, context. Oh, it's not this. It's this dot context. There we go. Same thing down here. this dot tree view, this dot context. All right, we're cool there, we're cool there. So whenever we just set the payload, we want to also then say this dot add text to view, the payload we just added. We're going to do the same thing here. We actually probably could do it inside of that constructor if we wanted to. But for right now, for time, we'll just do it here. Otherwise, we'll ask the left tree to add this guy, so let's get done. That'll add the payload. Otherwise, ask the tree to do it. Okay. And that's our add button pressed. So let's go back out here to this guy. We'll go down to our, actually I think wasn't my trick last time. I ran it first and then the on-click thing worked. So running. Now I'll go down to on-click. Here's my add button pressed. Run this guy again. All right, so we'll add a 5. Add a tree. Oh no. What do you yell about? Oh, it's probably that method. Yep. Five. Add a tree. Nope. What did the guy complain about here? Null pointer exception. So it's got to be with one of our add methods. I was rushing there at the end.
I think it's finding the method still on the maybe.
It's not finding the method. You think that's still it?
I think it might still be it.
Well, I should then be able to just go down here.
Well,
Oh, maybe it's the other one. Maybe it's that one. So I clicked the main activity one before. Well, we'll look at the beginning of next class. All right, so no homework over the weekend. Hopefully most of you are coming to the hackathon. We'll get this guy, I mean, it's probably a stupid little thing. Fix the beginning of class next time. We'll talk about lexical address, and then we'll go from there. Sound good? All right, I will hopefully see most of you on Saturday. 8 a.m. is when you get your starting breakfast, blah, blah, blah. And then 8 to 12 is stuff, programming stuff. Then we take a lunch break. We're going to have some alumni come and talk about the jobs they have, and then we'll have the rest of it after that. Okay.